All right. Sorry. We're going to talk about simple exponential equations when the basis cannot be adjusted to be equal. Okay? When the basis cannot be adjusted to be equal. Okay? So each one of these, and I say simple because there's nothing you have to do prior to. You're the man. Oh, you want to see these? So all of the like preliminary stuff that we would have to do prior to conducting the main step here is already going to be done. So basically what I'm trying to get at is when we try to do what we're going to do right now, the variable term needs to be isolated. The variable term needs to be isolated. Everything we work on today, the problem's going to start that way. Okay? Tomorrow, we'll make it a little bit more difficult, and we'll have to get to that point before we implement what we're going to do today. Okay? So these are simple exponential equations. Basis cannot be adjusted to be equal. So, for instance, if I say, what is the answer to 2 equals 3 to the x? Okay? You cannot easily, okay, because none of us think in irrational numbers, none of us could easily, off the top of our head, say, oh, change 2 to this number, change 3 to this number, and we can compare the exponents. Okay? Last week we had, maybe instead of 2 on the left-hand side, we had 9. And you could take the 9 and rewrite it as 3 to the second, right? And then you would be able to say, okay, well, 3 to the second equals 3 to the x, so x must be 2. Here you cannot do that. All right? So when you cannot do that, okay, even if you can do it, this process will work even if you can do it. Okay? What you're going to do is you're going to employ a procedure of logarithms. Okay? Remember, exponentials, what is the inverse of an exponential? Logarithm. Okay? So just like any other equation, if you're trying to undo something, you use the inverse. So if I have addition, I use the inverse subtraction, right? If I have multiplication, I use the inverse division. Okay? Here, we have an exponential. We're going to try to undo the exponential. So we're going to use the inverse. Okay? So, what we're going to do is we're going to take the log of the right-hand side. Okay? So all you're going to do, on the right-hand side, you're going to take log, write log out in front, and then write 3 to the x. That's all you're going to do. You're going to input a log of the right-hand side. And basically what we say is we take the logarithm of the right-hand side. Okay, but the right-hand side stays exactly as it was, but with the word log out front, right? Now, in every equation, if you multiply both sides or one side by something, we have to do the other side. Same thing. If I divide one side by something, we'll have to do the other side. Same thing, right? If I add something to both or one side, I got to do it to both sides, right? So in all equations, to keep them balanced, whatever you do, you have to do to both sides, right? So what did we just do to the right side? We took the log of it. So what do I have to do to the left-hand side? Take the log of it, okay? So I'm going to write this as log 2. Okay, now, here's a situation. We can talk about this as we move through, and we can see multiple examples of this, but it does not matter what log you use. No. So that's what I'm getting at right here. The subscript that usually goes right there, okay, and right there, that's what you're asking about, right? Those subscripts, because those are the base, right, that we use in a logarithm, when we do this, they can be anything that they want to be as long as they're the same. Okay? So what's one of the best ones to choose? 10. And the other one is, if you remember, not 2, not 3, it was between 2 and 3. It was a letter. You guys remember E? Okay? And that would be the natural logarithm, right? Okay? So, you can use either of them. Okay? You could use log base 3 if you want. You can use log base 17 if you want. There's no condition that says that it matters. Okay, and I'll prove to you that doesn't matter. But just for writing purposes, okay, for doing these problems on your own, just write log, because then it's understood in log-based sense. Okay, so now here's my question. When we have log of 3 to the x, okay, we still have our variable in an exponent. But you guys remember the rule that said if I have log of a to the c, we can rewrite that. We bring the c out in front and rewrite it that way. Remember that? Okay. So now that thing right there can be written out in front. So we're going to rewrite this as log of 2 equals x times log of 3. Does that make sense to everybody? Okay. And I haven't been doing it, but if you want to put parentheses around those things to make it cleaner looking, to realize what we're taking the log of and what we're not taking the log of, that's fine. Okay. Now, here's where people get confused. Okay. What do I do next? How are these two things over here, what operation is sticking these together? We got two things. We got x and we got log 3. What's sticking them together? What operation? Multiplication. Okay. What I want you guys to see is that log of 3 is that number right there. Does that make sense? And log of 2 is that number right there. So really, if I look at this equation, now those are irrational numbers, meaning they go on forever, they never repeat. So if I cut them off here at that 2 and that 4, then I really don't have log 3 and log 2. Okay? Or if I cut them off here at that number and that number, I really don't have log 2 and log 3 anymore. But to make a decision on what we're going to do here, I'm going to rewrite this equation using these values. So I'm going to go 0.301 equals x times 0.477. That's exactly what this says. Does that make sense? Okay. So normally, if I've got a number over here times x, don't we usually put the x at the end, right? So what would you do in this equation right there? Going back to Algebra 1, Day 1, what would you do with that equation to solve for x? Divide both sides by 0.477, right? But what was 0.477 as an exact value? It was log 3, right? So what I want you guys to see here is that when I divide by log 3 here on the right-hand side, the reason we're doing that is because it is a coefficient. It's just an irrational coefficient. So we write it as log 3 because that irrational coefficient, that irrational number cannot be written out exactly. We can only write it out to a certain precision. 2 decimal places, 3 decimal places, 4 decimal places, whatever we choose. If I write it this way, it's the exact value. Does that make sense? So if I divide the right-hand side by log 3, what do I have to divide the left-hand side by? Log 3. Okay. And now we get log of 2 divided by log of 3. And these cancel on the right-hand side, so what am I left with? I'm left with x. Okay. Now, if I were to give you a number line, and I gave you like a thumbtack, and say, go put this thumbtack on the number log 2 divided by log 3. Does anybody know where to put that? No clue, right? Okay. You might think, well, if I take 2, if I take 3 and raise it to the first power, I get 3. That's bigger than 2. So maybe the x value that I have to choose is probably less than 1. Okay, we'll see if this number here ends up being less than 1. But what I'm getting at is you have to end up using your calculator to actually evaluate this. And pay attention to, on Math Excel, they'll ask you 2 decimal places, 3 decimal places, that kind of thing. But they only want 2 decimal places, 3 decimal places, whatever, once you have found that. Okay, so we're going to type that in. We'll go log of 2 divided by log of 3, and I get that number right there. Okay, so let's see if that makes sense. And we said it was less than 1, right? If I take 3 and raise it to the 0.630929753571, does it spit back the 2 that we were looking for? Okay, so that's how we end up solving exponential equations when we do not know how to take their bases and rewrite them the same. I don't think anybody would have known to take, that 3 and rewrite it as 2 to the 0.6309. That makes sense? Nobody's going to do that. Okay, so we have to go through that procedure to do that. Now, like I said, it doesn't matter what the base is. So let's see if we, if I type in, do it this way first, function. All right, so if I go 2 divided by 3, okay. So if I put in a base of like 5, and then a base down here of 5, do I get the same number back? If I put a base of 15 in, do I get the same number back? If I put those bases in, do I get the same number back? So if the base doesn't matter, a lot of times, because our counting system is a base 10, right? Okay. A lot of times we'll use just the common log. Okay. And other times, depending on values that show up in the problem, we might use, I like to use this one instead of any of them, because when I write ln, I only have to write 2 letters instead of 3 letters. Okay. But remember what ln is. Ln is base E. So ln is really putting E, the number E right there, and the number E right there. And remember, E is that value there. Okay? So the argument is, when we take the log, it does not matter. Is everybody okay with that? Yeah. Neighbor might have something completely different than what you have. Okay? But it does not matter because the bases don't need. Now here is one thing to think about. Okay, I said the bases don't matter, but they have to be the same. So I can't say like log base 5 and log base E. Does that make sense? So in the problem, if you say I'm going to go with log base 10, then it needs to be log base 10 everywhere you see a log in the problem. Cool. All right, so let's do another one. I think once your name is on the door, you can make decisions like that. All right, take a shot at that one. Before you do anything, okay, 5 to the first is what number? 5, right? What's 5 squared? 25. So 5 and 25 is 17 between those. 17 is between those. So our answer for x should be between 1 and 2, respectively, right? Okay. So when we're done, we'll make sure that happens. So you can always do these, for the most part, with an understanding of what your answer should look like before you find your answer. All right, so what do you do first here? Okay, so you're going to take the log of the left side, so it's going to be log of 5 to the x, and you take log of the right-hand side, so log 17, right? Now, if I have log of a to the x, we can rewrite that. We can take that x, put it out front, and say x log of a, right? So we'll take that x and move it out in front. So it becomes x log of 5 equals log 17. Okay? Now, log of 5. Anything about what this means? Log of 5 is the way we written it because we chose base 10, right? Okay? That is a coefficient. That's a symbol for the number that I have to take 10 and raise it to get 5. That's what that's saying. Okay? But nonetheless, this is a symbol for a number, right? That thing right there is a coefficient. Okay? So how do I get x by itself if I have this coefficient? Divide. So divide by log of 5. You get cancel, cancel. Come over here, divide by log of 5. So x is log 17 divided by log 5. So we'll see what that turns out to be. Log 17 divided by log 5 gives me that. Then we say our answer should be between 1 and 2. And it is. So now I should be able to take 5 and raise it to the 1.76 0.374427772. Now I don't get exactly 16.99, or sorry, I don't get exactly 17. I get 16.99999, which tells me that 2 is rounded. Okay, but is that pretty close to 17 to give us the proof that we're done? We're right. Okay, let's try this one. Let's go 4 to the 3x equals 21. 4 to the 3x equals 21. Okay, still a simple log or exponential equation because I don't have to do anything to isolate the 4 to the 3x, right? That's all by itself on the left-hand side. So, can't change 4 and 21 to the same base. So we have to revert to this process of using logarithms. So I'm going to take the log of the left side, so it'll be log 4 to the 3x equals in log 21, right? Okay. What are you going to do next? Okay, so you want to take that 3x out in front. That's good. Okay. So take my 3x out in front. Get 3x log now of 4, right? Equals log 21. All right. Now, you can do a couple different things here. Okay? Why is this different than any other problem we've done so far? Say again. Right. So the exponent, that was a 3. Normally, the problems we saw so far, that was just an x, right? A 1x. So when it came out front, it was still a 1x. Now, it's a 3x out front. That's different, correct? So here's what's going on here. We can do a couple different things. If you want to stay consistent with what you've been doing and you divide by the log of 4, that's fine. Divide by log of 4 here, divide by log of 4 there, okay? And you get then 3x equals log 21 divided by log 4. Is that okay with everybody? But I don't want to solve for 3x. I want to solve for what? X. So what am I going to do to solve for x here? Divide by 3, okay? Now here's my question. I don't want to, because I've already got a fraction on the right-hand side, and I don't want to divide a fraction by a fraction. So if I want to divide by 3, what could I multiply by that is identical to dividing by 3? 1/3, right? Okay. So if I multiply this by 1/3, those are going to go to 1x. If I multiply this by 1/3, I get a 1 up top, and I'd put a 3 on the bottom, right? Does that make sense to everybody? So here's my question, because I don't think we're ever going to want to really do that. What could I have divided by up here instead of log base 10 of 4? What could I have divided by all at once to get this thing down here in the bottom? Because right here, those canceled, right? Could I put a 3 here and those cancel as well, and then a 3 there? Does that make sense? Does that get me directly to this with 1x? Okay. So what I'm trying to show you here is a situation where in the past you might have had something like 2x times 3 equals, let's say, 12. Would you divide by 3 and then divide by 2 again, right? But couldn't you at the same time just have divided by a 6? Because that 2 times 3, does that make sense? And that's all this is here. When I say 3x log 4, 3 is part of my coefficient, log 4 is part of my coefficient. So if I wanted to rewrite it as like this, if I could have gone 3, so 3x log of 4, that is identical to 3 log 4, whatever that number is, times x. That's my coefficient. Now, a lot of times we see this with equations that have words in it, like log. When we talk about trig, we have sine and cosine and tangent. Those are words inside equations. Usually, if you have words inside your equations, you will always put your variable first. They're kind of like with radicals, okay? And for the reason of, and I think some of us are seeing this. If I write 3x log 4 like that, there's nothing wrong with that, okay? But if I write it as 3 log 4x like that, nobody knows whether that 4x is in the parentheses here or if it's out of the parentheses, because it means two different things. Does that make sense? So to eliminate that confusion, they always write the x out in front. Okay? But that means that log 4 is still a component to a coefficient, and so is the 3 here. So now when we divide that out on Desmos, okay, so we got log 21 up top. I got 3 log 4 on the bottom. Okay, so that means if I take 4 raised to the 3 times 0.732052903796, do I get back the 21 that we're looking for? Okay. So you can do that division if you've got a exponent that has a coefficient here. When you go through the division down here, you can either do it in 1 step or 2 steps. It's totally up to you. Okay. Some people that do it 2 steps are going to do it like this. They'll get that answer, log 21 divided by log 4, because of what we had initially, and then we'll take that and divide it by 3, and you see that it still does give you that value that you needed. Okay, but putting that 3 there is exactly the same as putting that 3 there. Is that all right? Can we do some of this stuff if I released you to work on your assignment now? There's 9 questions. I think if you work on that now for the next 10 minutes, you'll probably get most of them, if not all of them, done. Okay, they're all of kind of the same difficulty. Like I said, tomorrow we'll increase it a little bit. We'll add 1 or 2 steps to the process. So you guys can start on that now, and then I'll be due on Wednesday.